One of the functions of the router is to connect two or more networks together. This is a picture of one of the routers, and this is the icon of the router here. For instance, if we take our home router, I want to mention that we have routers everywhere, at home, at the office, at the stores, everywhere, at restaurants, everywhere we have routers. So let's take our home network. We have a router at the home. It may be Wi-Fi router also. This router, usually some simple routers, probably TP-Link or cisco models, some kind of home routers, usually have two ports. Not two ports, I mean two interfaces. Router may have several ports, of course, but some cheap routers, home routers, have just two interfaces. One interface is connected to the ISP, to the provider, to the internet, okay, and second interface is connected to our home network. Here are our devices connected to the home network, right? So this home router has two interfaces, and on each of these interfaces we have separate networks for sure. So interface connected to the ISP has one network ID, network address, for example. This network address connected to the internet service provider is, for instance, 1.1.1.1. Doesn't matter which IP address is this network address. I mean network address. Sorry, not 110. The network address. And network address connected to our home network is often we use this by default. Routers provide this IP address 192.168.1.0 or 0.0, but most often we can see this network ID, network address here in our home network. So as we have two networks here, this router, without this router we wouldn't able to connect to the internet. So for this router, our devices in our network are able to connect to the network, to the internet. I mean, they're connecting using this router, they're connecting to the internet. So in this scenario, our router connects two networks together, and at the same time router blocks any access from the outside network and protect our internal network from some access or from some attacks, right? And this router in the picture, you can see that this router has several ports. This port with blue label is a console port. I'm talking about Cisco routers. Not each router has this console port. If we take TP-Link router, they don't have console port. Or cisco routers, they don't have console port. Cisco routers have console ports. We use this port to make initial configuration of this router. If we have new router, if we just bought new router, unpacked it, and we need the first configuration, we need to do initial configuration, we have to connect to this console port and do this configuration. If we'll try to connect to the Ethernet ports, as you can see here are two Ethernet ports. If you try to connect to the Ethernet ports on the new router and try to configure this router, we will not be able to connect to the Ethernet port because this router doesn't have any IP address assigned yet. and without any IP address this device isn't reachable. So we need firstly to connect to the console port, assign an IP address to this router, enable these ports, etc, etc. We should configure, we should prepare initial first configuration, minimal configuration, so later we would be able to connect to this router using network connection. So for the first time you always need to connect to the console port, configure your router, and later, of course, later you can use these two ports. Also, these ports are used to just connect this router to the network, to the switch. So in this picture, in this router, we have only two Ethernet ports. What does it mean? If we take our home network or small office network, let's take this router icon. We have, as I showed you before, this router has two interfaces. One interface is connected to the provider ISP. For instance, this interface is connected to the ISP, to the internet. The second interface is connected to our home network, right? This is our home network. Well, this interface is connected to the home network where our device is connected to. It's okay now. Okay, the same thing I've showed you here, the same thing here on the picture. But if we have more than two networks in our office, for instance, we have 4 networks, we need to install, we need to connect to this router 4 networks. Here we have one department and one department here, but this router doesn't have enough ports for that. What should we do in this case? As you can see in the picture, we have 2 modules here. This is the first module and this is the second module. We can remove this module and put additional module, additional weak module with additional ports on it. For example, this is our module, this is our weak module. It has 4 Ethernet ports. It's good. We put this module here in the router, and now we have 6 Ethernet ports. So in this case, for these 2 networks, we can use these 2 ports, and we have 2 ports in spare. We can use these 2 ports for communicate 4 networks together. So in this case, we need additional modules. Let's talk about labels, Ethernet labels. The label of this Ethernet card, Ethernet ports, for instance, this router has 2 ports. The label will be as follows. For the first port, fast Ethernet 0/0. Second port, fast Ethernet 0/1. What they mean? 0/0, 0/1. This part, the first part, indicates the module number. As you can see, this switch has integrated module. This is an integrated module which includes 2 ports, and this router has additional modules. Yes, external modules which we put here. So the module number may be 0. It depends on the router model. Some routers have different module numbers, for instance 1 or 2 and so on. In this case, the module number is 0. So we have one module with 2 ports. So port label for the first port will be fast Ethernet. If this port is gigabit, so in this case here will be gigabit instead of fast Ethernet. So fast Ethernet 0, the number of the module, and this 0 is the number of the port. But for the second port, as the module is the same, so the module number will stay the same. Module number is 0, port number is 1. It means port 0 on module 0, port 1 on module 0. If we have additional module, and here we have, for instance, 3 ports, So in this case, labels of these ports will be as follows: fast Ethernet 1/0, fast Ethernet 1/1, and fast Ethernet 1/2. It means module is the same, ports are different. Port 0 on module 1, port 1 on module 1, and port 2 on module 1. I hope you understand this, you get this. You have any additional modules with extra 2 ports. So in this case, the number of the module may be fast Ethernet, the label of this ports will be fast Ethernet 2/0 and fast Ethernet 2/1. It doesn't matter which number of this module we have. It's just an example I'm showing you here. It depends on the module. Some modules have different numbers. So you will see the labels like this. Also, we have here serial ports. These ports are serial ports, as you can see, serial ports. Serial ports is a very outdated port. It used before to communicate instead of WAN interfaces, instead of Ethernet ports. They were to communicate routers together. But nowadays, you can rarely see such kind of ports. Okay. Routers. What router does actually? It controls broadcasts and forward directed data packets between networks. As you know, switches work with broadcasts. Switches send broadcast signals, but routers don't send broadcast signals. They block broadcast signals, so they control broadcast signals. For example, if switch is sending broadcast signal to the router cannot forward these broadcast signals to all its ports. It's impossible. It blocks it and forwards unicast, for instance, signals to the other networks. And for example, if we take our router here, this interface is connected to the internet. We have a switch here which is connected to the router. We have computer 1 and have computer 2. If computer 1 is going to communicate with computer 2, they're connected to the switch. If one is going to communicate with computer 2 inside our network, just switch. This is a layer 2 switch, by the way. This switch just transfers. This switch also works with MAC addresses only. The switch cannot work with IP addresses because it's a layer 2 switch. Switch just takes this information and transfers it to the second computer based on MAC addresses of these two computers. It's okay now. It's okay. But if we are going to, if we have web server somewhere in the internet, web server number 3, for example, maybe this website is itbaku.info, for instance. If our computer 2 is going to reach this website on the server, what it does, our computer, in order to reach this website, we have the name of this website, www.itbaku.info. We have the name of this website, but it's not enough for computers to connect to the website. Computers need to know IP address of the server. So first thing the computer do is doing DNS lookup. DNS lookup, asking DNS server. Computer knows the IP, knows the name of the website, and computer send request to the DNS server to get the IP address of the server. So DNS server replies, sends the computer IP address, and computer already knows the IP address of the server. For example, the IP address of the server is 1.1.1.1. Okay. Now computer knows the IP address of this web server where the website is located. Okay. So computer need to connect to this website, but computer have to say the switch where to forward its requests to. Because if computer says to switch that switch please forward me, or get the computer for me, or get me to the server which I want to visit, get me to the website. If computer asks this switch and gives the switch just IP address of the server, the switch will not be able to forward it, because layer 2 switch cannot work with IP addresses. Switch doesn't know what is it. Switch will not understand this computer. So in this case, what computer should do? Computer generates a packet. As you can see, here's a packet computer generates. For example, in the data field, computer generates a get request. Get. The computer wants to get some information from this website, so it generates get request. So this is a packet where a computer includes all the information, and this packet going from each device through each device to another device, and so on. So computer generates get request and put information here. Source IP address, it's the computer's IP. Source IP address is the computer's IP address. For example, 10.1.1.1. The computer puts its source IP address here and puts destination IP address. Destination IP address will be web server's IP address, 1.1.1.1. because the computer puts this information here. And if computer send just this part of this packet to the switch will unpack this packet and look into it and see, okay, source IP address, destination, what is it? What does it mean? I don't understand. Sorry computer, I cannot forward your request. So in order to switch to help this computer should include MAC addresses in this packet as well. So computer puts its own MAC address, this is computer's MAC address, here is the source MAC address, and destination MAC address. But which destination MAC address computer should include here? Computer doesn't know anything about this server's MAC address, because the server is outside of its network. It's not here. It's outside of the router, outside of the network, somewhere in the internet. This computer doesn't have any information about destination MAC address of this web server. So computer knows that in order to get the information, to get the server, computer should forward all requests to our router. This is the only device which is connected to the internet. So this device will help us to get this web server. So computer puts MAC address of our router, or this interface, MAC address of this interface of our router in the packet, and sends this packet to the switch. Switch opens this packet and looks here. Source MAC address, this computer's MAC address. Destination MAC address, okay, destination MAC address is router MAC address. Okay, let's forward this request to the router. Let's ask router to help this computer to get this web server. Okay, in this case, router receives this packet, opens this packet, sees, okay, source MAC address is computer's MAC address. It's good. Destination MAC address, my MAC address. Oh, probably computers wants something from me. But router, in comparison with the layer 2 switch, router work at layer 3. It uses IP addresses. Routers know what IP addresses are. Okay, they understand what is IP address. So router looks at this part of this packet and sees source IP address computer. Okay, destination IP address, this IP address. Oh, it's not mine IP address. MAC address is mine, but IP address is not mine IP address. Okay, so it's this packet isn't destined to me. It's destined to some server on the internet. So I should forward this request further. But where to forward this? Every router has its own routing tables, and we can call it routing map. As you can see, relies on IP-based routing table. So every router has some routing table with routing maps, where to connect, which routers to use, because this router is connected to many routers. As you can see, this router may have some different interfaces, maybe this interface, or this router, ISP, provider's router, is connected to has different interfaces connected everywhere. So router has its own MAC routing table, IP-based routing table, and forwards these this packet further. Okay, so in this case, router uses IP, switch uses MAC addresses. I hope you got my point, and thanks for watching.